I took this photo taking my dog for a walk the other day just around the suburbs because it kind of relates to what we want to talk about in this question, and that's those big towers that you might see, hanging around everywhere and crisscrossing our nation, transferring energy, electrical energy from city to city in our country. And the question really relates to, why do we bother doing it at such a high voltage? So as the question says, these are being transmitted at 330,000 volts around your street, up and down your street. You might see some poles like this. The top wires are transmitting energy at 11,000 volts and the bottom wires are doing it at 240 volts. Now, if you live in a fancy suburb and the wires are put underground, it's all still the same. It's just that they're running underground. The question is, why do we do this thing of stepping the voltage up and down? Well, the advantage isn't so that we can build big towers because they cost money. They're actually a disadvantage of doing this. What is the advantage? Well, the advantage ultimately is around about not losing so much energy. So as we transfer energy and electrical energy from our generators to our houses, and of course, these days with solar, like I've got on my roof, it's between houses as well, so it's both ways. But nevertheless, it's all about moving energy around. And these wires are made of metal, and so they'll have some kind of resistance. And so power equals, as you know, voltage times the current. And Ohm's law, we know that V equals IR. So we can substitute the IR in the place of the V there, and what we get is power equals IRI, or power equals I squared R. Okay, so now look at this equation here. That is the power that's being transformed into a different form in the component. In this case, the component we're thinking about is the wires. So we can think about this as a power loss. All of that power, all of that energy per second, what it's doing in the suburbs is it's making the wires warm, which is just making the air temperature warm. Now, that's of no benefit to anybody. And so, yes, the law of conservation of energy holds, but we'd still consider that a loss of power because it's not sort of what we want to have happen. And so our power loss in our wires comes down to, well, we've only got two handles that we can maneuver right here to change the amount of power that we lose from the system. The first one is by reducing the resistance of the wires, and we can do that, but to do that means fatter wires, which means heavier towers to hold up the fatter wires, or better quality metal, which costs more money. And so we do that as much as we can, but the other really significant and better lever to pull is to reduce the amount of current. Now, of course, we can reduce the amount of current by everybody reducing their demands and wanting less power, but that's not kind of really going to help us. So how else can we transmit the same amount of power but at a low current? Well, it comes back to power equals VI. If we increase the voltage, we can reduce the current to transmit the same amount of power or energy per second, and that's exactly what we do. But because the power loss in our wires equals the square of the current, actually changing the current is really, really effective. So for every amp that we decrease the current, every time we say double the voltage and halve the current, we get a 4 times reduction in power loss. And if you think about the difference between, what if we just transmitted everything at nice and simple at 240 volts around the nation versus, say, our long distance transmission at 330,000 volts, you'll find it's orders of magnitude of energy saved, and therefore, less cost for the power companies because they have to fund that energy loss. You only get charged for what arrives at your house. They have to pay for all the energy losses. So they're very interested in trying to minimize that. And of course, the reason we have 11,000 volts is because everything's a trade-off. The higher the voltage, the less the energy loss. But if it's only over a shorter distance, we can do with a shorter tower that costs less money to build and a slightly lower voltage. And so the voltages that we use are this lovely trade-off between saving energy and reducing the amount of power loss and therefore money, and the convenience around how tall the towers we have to build.